Okay, hello. So thank you for bearing with us to the end of this tutorial. This is the final question. Now, hope this session has been useful for you. Uh, in typical cases, I would have preferred to have this face-to-face or at least asynchronous. But I think yeah, so we do what we can. But we are always here to support. So if there are any parts of this tutorial that you are still not very clear on, just let us know and we'll do whatever we can to help to support you. So I'm going to share my screen now. So the question number 5 is on the Towers of Hanoi problem. The Towers of Hanoi work in this manner. You are given 3 poles. So 1, 2, and 3. So 3 poles. And what you do is you are supposed to shift. Sorry, you are also given a number of disks. And you're supposed, and these disks all have different width. The objective is to shift all the disks from one pole to another pole. So from the front pole to the 2 pole. But there is a constraint. The constraint is my disk cannot be on top of a smaller disk. So that is the constraint that we have. Another thing that we are provided with is at the very beginning, your disks are all arranged in a very nice fashion, from big to small. Okay. So this is the constraint, or not constraint, this is the so-called the problem. Okay. Let's do a very simple example. I have 3 disks. Imagine if I have 3 disks and we call these poles A, B, and C. And the disks are here, A, B, and C. I think for simplicity, yeah, let's call this one RGB. RGB. So let's see if I want to shift all my poles from A to B. So the first thing that we do is, let's say A wants to be shifted to B. What we do is, let's do this in the more typical way. Let's assume you're playing the game. So the first thing we do is we take away this one. We move over here. So left with this, we have to move G to this. And then now we move R to here. Okay. And now I move B to this. So there's no thing here, nothing here anymore. But I can't move R to this one directly. I have to move R back to my intermediate pole. And now I can move G to this pole. And now I can move R back to this pole. So I have successfully shifted my disks from A to B. And at no point of time do I have one disk that's on top of a slightly smaller disk. Okay. Notice that in the way we are shifting, one of the things we always do is that we always try to or rather we always make use of an intermediate pole in order to shift the disk. Okay, so for example, in the last shift when we already have RGB here and we have R and G here, we could not shift this directly to B. What we have to do is we have to make use of the intermediate pole, shift R here, and then shift G to B here, and then shift R to here. So this is how this is the steps we take to shift the disk around. In the question, it actually gives you kind of a hint how we do this. And I'm going to tell you how to do it in a conceptual way. Conceptually, what the question is saying is, let's say I want to shift from A to B. What I do is, I will consider everything on top here as one single unit. And I'm going to say that I don't know how I'm able to shift it to my intermediate step. I don't know how to do it, but I think somebody recursively should know how to do it. So I will say, okay, move my disk from the top to the second last disk, move it to my intermediate pole. And I'm left with this. And then I said, okay, now I know how to move my final disk to the pole and move all my disks over here back to my target pole. Okay, so this is what conceptually the Towers Hanoi solution that they provided you with is talking about. Okay. Once again, it says that with any disk, assume that the top all the way to the second last can be moved as one unit. And we are going to say that we are going to move the unit to my intermediate pole. And then move my last disk to my objective and move back the rest of the disk back to B. Okay. So let's say we use an example. It is very hard to look at the code to understand this, which is why I'm drawing so much. Let's assume that we want to move these 3 blocks from 2. Okay, as what we said earlier, we want to first move these 2 items to this. But firstly, I don't know how to do this. And so we will call our recursive function on top that will decide how to shift these 2 blocks to this. Once we so right now, initially the first call was this 2 blocks. The second call is these 2 blocks. And these 2 blocks, actually, this only one disk, this only the second disk. So we can so actually what will happen is we would also recursively call it until the terminating condition, which is when the number of disks is just 1. When the number of disks is just 1, then it will just be that single disk which is moving. Okay. So the first thing we do is we will say that I want these 2 disks to move to let's say intermediate to I. Okay, move to I. So I'm not sure how we can do it, but we think that we can do it somehow. So when we say that we want to move these 2 blocks to I, what we are going to say is that the target of these 2 blocks is going to be I. The target of these 2 blocks is going to be I. Okay. And let's say that we not too sure how to move it over to this block. What's going to happen is that we are not sure how to move it to this block. And now to move it to this block, it is going to call another recursive call, which is at height minus 1. At height minus 1, we know now that the target initially was at this pole. But to move it to this pole, our target now for this pole now changes again to this pole over here. Okay. This may seem very strange, like maybe the way I'm saying it sounds a little bit strange. But what is happening is that as I carry out this recursive call, my target of where I want to shift the blocks to constantly changes. It constantly changes because in order to move my target of these two blocks to this, I need to use this now becomes my intermediate block. And because this now becomes my intermediate block, when I go down to my single block, now this becomes my target block. And so in the call eventually, what happens is this block get moved. This R, G, B, R gets moved to here. So at last, one of the blocks is being moved. Now we call in this disk, this is supposed to have the target to be this block. Now I can move this G to this block. This gone. And now this gets moved back to this block. And it's gone. So my first idea of, I don't know how I'm going to move this block, but I know somehow that this block is going to be moved here, has already been done. So indeed, now this entire block has been moved over here. And my B will now be shifted to my target, which is MI2. I hope this is not too confusing. Yeah, but it just happens that at every single point of time, my target and my to and my from changes all the time. Maybe let's call this X, Y, Z. Now these blocks are at Z. I want to move these two blocks to Y. Right? I want to move them to Y. So my idea is, I don't know how I'm going to move my Z blocks to Y, but I know that I can move my blocks on top to my intermediate, which is my X. And then I move my G, and then I can move my blocks at X back to my Y, which is what exactly we are doing. So over here, my Z now becomes my initial place. My X becomes my target. Sorry, my Y becomes my target. My X becomes my intermediate. And so R gets shifted to my intermediate. This is gone. G now is able to be shifted directly to my target of Y, and this goes back to my target of Y, and we are done. Okay? The key thing is whenever we are doing this towers of Hanoi, we are imagining that the recursive will take care of the blocks above. I just need to take care of my current block at the very bottom. And that is the key thing. Okay, I hope I'm not too confusing up to now. Maybe I'll try to explain this in another way later on. Okay. At this point of time, let us look at the code. So it says that I want to move a tower first, which is the top part, to intermediate pole. And then I move the last one to the final pole. And then I move the intermediate pole to the final pole. Okay, so that is the so-called algorithm, the recursive idea. What then is my terminating condition? Okay, recall in question number 1, our terminating condition is when our height is equals to 0. This will also be the same. The terminating condition is when all the disks in the pole have been shifted up and there's only left one single disk for you to shift. So that would be the terminating condition. So as long as my height is 1 or above, I need to do something. Else, if it's 0, means that I'm done already for that part of the recursion. Okay. So I need to have two functions. The first function is known as the move tower. And as I said earlier, I need the height and I need something else here. Oh. If my height is equals to or less than 1, I can return. So this is my terminating condition. If my height is less than 1, there's nothing I can do anymore. Okay. Now the thing is, if my height is 1 or more than 1, what then do I do? If my height is more than 1, I can move tower height minus 1 something here. Then I move my this and then I move back the tower. Okay. So that's all. Now we have our terminating condition. You have our reduction condition. The last thing, which is the one that is a little bit more challenging, is what is our recurrence condition. But fortunately, the question gives us a little clue what this recurrence condition can be. What the question says is that it seems that it requires 3 poles. So we probably need to play a little bit around with these 3 poles. So let's say we have we have an intermediate pole, we have the final pole, we also have the original pole. Okay, these 3 terms are not as intuitive, so I'm going to rename them from pole to pole and with pole. So these 3 are a little bit more intuitive. So the first thing we do is our from pole. So I have 3 disks. I will have to move my disk from my from pole to my intermediate pole. Because I want to move my disk, so I need to move it to my intermediate pole. So my target pole is actually my intermediate pole, and my so-called my intermediate pole becomes my target pole. So I need to move my disk from my original pole to the intermediate pole using my okay. Let me draw this out because imagine many question marks on your faces, although I cannot see your face. Okay. So what is happening is that X, Y, Z. So right now, I imagine that I can shift all this. I want to shift all my disks to Y. Okay? And so what's happening is that I am imagining that I can shift this whole part to Z. Then I shift this part to Y, and then I shift all the rest back to Y. Okay? So what I'm saying is that I want to shift this block to Z using the Y pole. Okay. Then after that, all the blocks, all the disks are at the Z. I will shift this to Y and then shift all the Z back to Y using the X pole. Okay. So this is essentially what the algorithm is saying. So I am shifting from my from pole where I am actually at to my with pole using my to pole. Then I move the single disk, and the single disk will be my from pole to my to pole. After that, actually, I can don't have this. I can just print to make it simpler. Move pole from I need this. Very good. So I cut down one function. Move pole from pole to pole. I move disk, and then after that, I move back my pole. Now my pole, my towers are at my width pole, and I need to shift it to my to pole using my from pole. Okay, so what it means is that now I have, so this is at the start, I shift my poles here from my X to my Z using my Y. Once it is successful, this is what it looks like. This is what it looks like. Then this is my single line of my curving. And then after that, I will shift my rest of my blocks, this, from my Z to my Y using my X. Okay, so this is it. This is the solution of the towers of Hanoi. So that is all. So if I want to move tower 3, let's say A, B, I should be consistent. I use X, Y, Z. Yeah. So this is it. So this is how we solve the towers of Hanoi problem. You can confirm. Right? Can I make this smaller? Okay. Let's confirm this. So firstly, I have 3 blocks, so 3 disks. Let's call it R, G, B. The first R, I shift from X to Y. So this will be R, this will become. And then I shift from X to Z. So G will be gone, this will be G. After that, I shift from Y to Z. R. After that, I shift from X to Y, this will be gone. This is B. Okay, so my first disk, my bottom disk is in the right position already. My bottom disk is in my right position. And so what is remaining is about these two to come up to here. And that's the last part where I shift Z to Y using X. So R gets shifted to this. R. G gets shifted to this. Oh, I forgot to so yeah, Z gets shifted to X, Z gets shifted to Y. So yeah, and then X gets shifted to Y, and that is the solution of the Towers of Hanoi problem. Yeah, so this question took some time to explain, but I hope after going through this in a little bit more detail, you have a better appreciation of this solution and can visualize it better. Yeah, so just imagine that you just need to manage the top part and the bottom last disk, and the recursion should take care of itself. Yeah. It may take some time to fully understand and appreciate. So, but to let us know how else we can support you and how we can improve on your learning journey. And I hope you have enjoyed this tutorial for this week. And I will see you again next weekend. Have a happy Chinese New Year. Thank you.